Oh. Did you get that announcement too?
I did, where it said recording in progress.
It says this meeting is being recorded.
Can you see my?
Yes, I can.
I know it's a little bit small. Ignore this graph starts down here at like 1290, which is a PWM signal going to the super servo on the transmission. So that's neutral for me. And 1500, which is basically this top line, is like the max that there's a max setting that I have it allowed to go. And this up and down is its attempt to get to 0.5 meters a second, which, and although the land is not flat, it's not crazy hilly either. On the left-hand side, ignore the fact that it's a negative. That's because I happen to have this on the left-hand side and it's reporting a negative, and I need to change that. But half a meter a second would be basically right in the middle there. And you know, it maxes out at 1 meter a second. It's just all over the map.
That's the actual measured speed off one of your back wheels.
It is, and I varied. I mean, this is just one screen print, and it's just one setting of my the two variables that basically are ingested into the code, which is I know it's not a real PID, but it's labeled as KI and KP. I mean, I varied these multiple times. These are, I was just doing forward. This is that nudge variable that I mentioned to you before. So I have multiple attempts at this. Bottom line is, I think my transmission, I'm frustrated with this speed control logic, and I'm not sure I can get there with this PID. So I'm of the mindset that I need to rejigger this code. And I don't know if that's just me being frustrated or or if it's really really true. But that's where I'm at. I don't think I have speed control to a point, and my suspicion is that speed control, I better get that speed control under control if I want to get the move base flex to actually behave in a reasonably controlled manner. But maybe I'm making a mountain out of a molehill.
No, I agree that you have to get your speed correct before you add any of the navigation stuff on top. And same thing with the steering, you got to get to the point where you can say, give it a command velocity message and have the thing actually do that. One point on those graphs you were showing, if you were to, instead of running your actual control code, just put out a PWM that's about 50% speed. So so the thing's going to be moving at a constant speed, and verify your graph on the left is showing you that you're moving at a constant speed. So that way that'll isolate down to whether or not you're reading the values incorrectly or you're generating incorrect values to send back out. First thing I thought of, just go out and push it. I suppose you could do that if your driveway slopes down a little bit, just point it down the driveway and start logging and just start pushing it at a constant rate, and then go back and look at that pink line and say, is that holding a relatively constant speed, reporting a relatively constant speed?
Yeah, I can do
Because
that. I mean,
it could be
just
you've got a problem there that you're just reading it incorrectly, which is going to be a problem. Or more than likely it is something in the code if you're trying to adjust the servo based on the speed that you think you're at.
I think what you're telling me is have a basic baseline that, say, 1400 gives me half a meter a second, generally speaking.
Yes, just put that in and then verify coming back out. It's not jumping all over like you see on the left there, but you want it to be, hold it at a fairly constant speed. And then, yes, if you can get a scale out of it that says that's the speed you think it is, if that's actually the numbers, if that's what the graph is showing, that would be good too, to know that.
Yeah, that would be, I think that would be a good way to like confirm I have physical control of the tractor.
Well, the thing I'm thinking is you want to know that you were trying to read the speed, that the speed that you're reading is correct. That was the debug step I was suggesting.
Yeah, remember I have two mechanisms for control or for measuring speed. One is the GPS, with so I've got an RTK signal and it's putting out a speed calculation or a speed value based on the movement of GPS position, as well as.
Have you plotted that? And
I have.
ideally plot that at the same time you're plotting this pink graph here. So you've got values coming off the wheels and values coming off the GPS.
Yeah.
Do those look the same when you do that?
I don't have it here handy, but I have done that in the past. I mean, I can do it again just to revalidate that they're basically in the same ballpark. But yeah, I'll do that again.
And that's good that you have the two sources like that, because you can directly compare the two back and forth and say, is it showing me a constant speed when I'm moving at a constant speed? If not, then you've got something wrong with your wheel sensor, speed sensor, or the code that's running it or whatever. So that would be a good thing to do.
Yeah, so I'm back to physical control of physical control. I think when I did this before, I'm like, it moves. I think I can go. So, Juan.
Turns out mine's not perfect either, but mine's working better than this, I think.
Have you done speed tests and plotted your speed?
I did, and mine kind of wavers up and down somewhat. It doesn't have massive changes like this.
Good for you. Do you have a protocol that you followed in order to do that test that you want to share?
What I did, I just put my mini tractor out in my front yard, and this is the electric one. This is not the gas powered one. And I went into my code where if you issue a command velocity and it's got a timeout that says after half a second or whatever, shut the speed down to 0. I just moved that number out to like 5 seconds. So I could type in one command velocity message, and that would supply a forward velocity and a steering angle. And the thing would start up and drive until I got that timeout. It would just automatically stop. So then if I go plot what it's doing, I could see the thing. I could see at time 0. I could see the thing would ramp up to speed. And it's supposed to hold a flat line like this, but it was actually, I could see it going up and down like this as my speed control was attempting to control the speed of it. But that way I just got down on my hands and knees and with the laptop in front of me, and I just type in, I pull up the last command velocity message, I hit enter. The thing was right there next to me. It would just start up, it would drive for 5 seconds and it would come to a stop. And then I could either just grab it and pull it back, or I could Actually, I think I was probably putting in something that I might have been using the joystick. So I'd say move the joystick, then drive it backwards. So next to me. That way I can just run the test multiple times by not even having to get up off the ground to do that. So I just start up logging first, and I don't think I was using bag files. I was just, I had the motor controller directly outputting to a text file. And then, as I say, that was the procedure I had. I just had it there next to me. I'd type in the command velocity. It would start up, it would drive, and then come to a stop. So that was my procedure.
And were you just issuing command velocity from a terminal window?
Yes.
So you were just typing a big long.
Well, it said something like Ross topic pub command vel with a bunch of numbers, and I didn't retype it. I just simply hit the up arrow to bring it back. So every time I wanted it to run again, I just hit the arrow. It could be that I had one that was saying go forward, one that goes backwards. And so I'd let it drive out 5 feet and it would log that. And then I just pull up the command. I might back up 2 command lines. I have one that says a negative velocity and let it run for 5 seconds and it come back and stop next to me. So maybe that's the way I was doing it. So I wasn't typing that stuff out every time. I just typed it in once I got it figured out. Just by hitting the up arrow on the terminal, it'd bring back the command line. I hit enter and it would run again. I tend to get fairly lazy when doing these tests, so I try to figure out what's the easiest way to make that work without doing a lot of typing, especially if you're sitting out in the sun where you can't see the laptop screen. It's good to know, good to know you can pull that command back up and get it to execute.
And because you're using an electric motor, I mean, you don't have the, you're not, just
I'm not mechanically controlling a transmission, and I don't care what the engine speed is because I don't have an engine. So I'm just saying control power to the motor and take the speed off the back wheels and run my PID to try to track my my velocity profile that I gave it, because mine has acceleration and deceleration. So it takes like half a second to get up to speed, and it's supposed to run at that constant speed until it gets the timeout, and then automatically loads 0 back in, then it'll decelerate down to 0 and stop.
Well, that's where I'm at.
But from a higher level, if you give it a command velocity message, whether you run an electric motor or a gasoline engine and a manual transmission, or a gasoline engine and a hydrostatic transmission, it's up to your code to say, take that command velocity. It says run at 0.5 meter per second, then it's up to your code to figure out how to get it to run 0.5 meter per second, regardless of what kind of setup you got.
Anything on your side, Jeff, you want to share?
I couldn't sleep again last night, so I laid in bed till about 4 o'clock in the morning thinking about this stuff. I thought we were going to talk about your steering today instead of your speed, and I think we're
lots of things wrong.
We're back to the point where you got to get the fundamental stuff correct first, and I think one problem you have right now is you've got apples. You got apples here and you got oranges here, and you're trying to merge the two together. And if you go back to the fundamentals, it says that command velocity by default is in rotational rate per second. So it says I want to turn 1 radian per second is how I'm going to define my steering. But then Tab Planner has a checkbox that says instead of that, we're going to substitute a steer angle into there. So one way, whichever way you're going to do it, that number either has to be in radians per second or in radians. And the way Matt seemed to write all the stuff, he took whatever numbers coming off the joystick, and he looks like he modified that to put out plus and minus 1 and shoved that into a command velocity message and sent that down to his vehicle. Well, at no point did anybody define, is that a number in radians, or is that a number of radians per second, or does plus and minus 1 represent plus and minus 100% of the steering? Because nowhere in there do you have an angle defined. So what you need to do in your code right now, you're taking the plus and minus 1 down into your Teensy, and you're saying take that value and scale that to my steering. So you're saying take the counts at full left and take the counts at full right and scale that to plus and minus 1. Well, instead of doing that, you could say measure your actual steering angle. And I haven't come up with a really clever way to do that other than, put your lawn tractor on the floor of your garage and point the thing straight, put a stick on the inside of your wheel and take a piece of chalk and draw a line on the floor so you know where the line straight is. And then take your steering and crank it all the way over the left hard stop. And again, put your stick on and draw a line there. And then before you're done, turn it all the way to the right and put a stick and draw a line. So now you're gonna have these lines on your garage floor that represent the forward angle, or the centered angle and the left angle and the right angle.
Mhm.
And you might have to extend those out down the point where they cross so you can see them. And then just grab a protractor and just measure that and get an approximate estimate. Is that 30 degrees? Is it 45 degrees? Is it 60 degrees? Whatever it happens to be, just write those numbers down. And then instead of scaling plus and minus 1 to full left and full right, take whatever that number is and scale that. So that way you're directly putting an angle into your command velocity. So if I put in 35 degrees, then it should turn the wheels until they match the 35 degrees. Instead of going off your joystick, which says plus and minus 1, which if you treat the joystick, if you leave the joystick the way it is at plus and minus 1, by definition, since you're using that with the TEB planner, that says you want a steering angle of +1 to -1 radians, which is probably not all that too far off, because you consider a radian is 57.3 degrees. So the question is, will your steering go all the way, when you turn full left, will that go a full 57.3 degrees, or will it only go 45 degrees? So it's still best to put something, once you figure out what that angle is that it'll do, put something in your code to clip it. So say, don't allow it to turn any further than that, or you're going to start smashing things. So at the lowest level, as you're doing your scaling, maybe you're even doing that with your, as you read that up with your magnetic sensor, maybe you have something that says, don't allow it to go more than this amount left and this amount right. And that way it keeps it from destroying anything. So if you leave that in there, as you send numbers down to it, if I'd say, well, turn it 10 radians to the right, which is way too big a number, and you don't want the motor to go over and hit the hard stop and keep trying to turn. So just put something in the code to limit that so you can't go too far. But I think if you would scale the stuff coming in to be an actual angle, because TEB Planner says, I want you to turn at, say, 10 degrees to the left or 20 degrees to the left, which it's actually in radians, but I don't know what the radians for that is. So it's generating an angle. It's not generating plus or minus 1. Now, when I went through the various pieces of code I saw that you had there inside of that command velocity mux, I was looking at it and I was expecting it to scale the joystick to an angle to send down to the tractor, but that's not what it's doing. It takes the number directly from the joystick, which is plus and minus 1, passes it right through and sends it to your vehicle. And then your vehicle is trying to scale plus and minus 1 to full left and full right. And nowhere in there do you have any angles being represented. But now when you switch over to the TEB planner, it's going to generate an actual angle. So if you go look at your command velocity mux code, the first thing it says, when it receives the number from TEB planner, well, we're just going to blatantly clip that to plus and minus 0.3, whatever. And again, there's no mention what that is, but it has to be in radians at that point. So 0.3 radians, 57.3 divided by 3 is 17 degrees is what it comes out to be. So it's saying, don't let the TEB planner give me an angle bigger than 17 degrees, which isn't very much. So as long as you're going to go straight across the yard, it's probably going to work, because if the TEB planner wants to turn more than that, then then it's just going to clip that and not let it do that. So the next thing in that command velocity mux, after you've clipped it to 0.3 is the max, then it does a scale. It says scale 0.3 to 1. So now it takes that plus and minus 0.3 and scales that to the plus and minus 1 that your tractor wants to see. So number one, that blatantly multiplies whatever the TEB planner is putting out by 3. So that's going to oversteer because of that. And the fact you clipped the TEB planner down to 17 degrees, that's going to not allow it to generate a big enough steer angle. So that's why in that those last direct messages I sent you, I said, well, your quickest thing is just go into your the command velocity mux code, and instead of clipping to plus and minus 0.3, change that to plus and minus 1. So that way it'll be whatever this arbitrary value from the joystick is, it'll be scaled the same as that. It won't let you turn any harder than that. And then the point down below where it says scale up from 0.3 up to 1, just bypass that and pass that number directly through. And that way you've got a good chance of the angle coming out of the TEB planner being close enough to make your steering work as is.
If we just fired up Turtlebot and didn't have lawn tractor running at all, and you're at an ODOM position of, I mean, pick a number, 10.10, and you said, okay, go to 5.5. What sort of command velocity value do you think move base would generate?
It's going to generate whatever it wants to get to that point. So see, you're adding a whole bunch of crap on top of this, to avoid the fundamental problem that you can't set an angle. Now, if you just fire up Turtlebot, I don't know if you're talking about a Turtlebot simulator or a real Turtlebot. If you have a real Turtlebot, well, first of all, it's differential drive, so it's not going to use steer angle to start with. It's going to use rotational velocity. And
but
just regular Turtlebot is probably going to have
your low-level controller is going to deal with the fact that it's tank steer versus Ackermann steering, right?
That's true, but again, fundamentally, you have to get your values to match. So whatever planner you're using, whether you're using move base without TEB planner, or you're using move base or move base flex with TEB planner, you have to look at what is that thing putting out. It's either putting out a steering angle or it's putting out a rotational velocity. So your vehicle has to know what that means. Fundamentally, down at the very, very lowest part. So you have to be able to type in a command velocity message, and since you're using the TEB planner with it set to steering angle, then your vehicle has to understand a steering angle. So if I type in command velocity that says move forward at 0.5 meter per second, and I want you to turn at half a radian per second or 1 radian per second or whatever, it has to know what that means and set your steering accordingly. So regardless of any of the navigation or your GPS or anything else, you've got to get that right first.
I don't disagree. I mean, and I'm just curious at a really simple level, as opposed to working up from, what's the angle that my wheels are at, so to speak, using the most simple robot there is, Turtlebot, and you give it a 2D nav go, what command velocity, what is the output? What is that? What is that value? Is it?
Well, to answer your question, if you're going to take Turtlebot and their navigation stack and you're going to put in an arbitrary point, the first thing it's going to do is say, I am here. It's going to fire up the global planner and figure out, it's going to draw a line from where you're at to the point where you want to be. And then if there's the obstacles in the way, that confuses it, but let's just ignore that for a moment. So once it gets done with the global planner, it turns it over to the local planner. The local planner says, where is my global path that was just drawn? So it says, I'm here, I need to move ahead a little bit, or maybe I got to move, say, 90 degrees to the right, in which case it's going to generate whatever commands it takes to make the vehicle turn. And so we don't know. It's going to be your command velocity, either steering or rotational velocity, is going to come out somewhere between 0 and whatever the maximum allowed value is. And we don't know what that is because it's going to decide that. So you can't just take this whole thing and say, well, what numbers are going to put out? Well, we don't know.
I get it. We don't know what values it's going to put out. I'm just curious if it's putting out radians per second or it's putting out something different than radians per second.
Well, if you're running the actual TurtleBot physical package, it's going to be putting out rotational velocity because by definition, the move base navigation system puts out rotation. Everything puts out rotational velocity except for TEB planner. There's got a little checkbox that says convert that to steer angle. So the TEB planner is the bastard child in the whole system here. So if you're running just a regular TurtleBot, by definition, any vehicle that's running the regular move base is going to put out rotational velocity. That's just the way they like to define their navigation stuff. But they've got a standard message that says command velocity is going to be forward velocity and rotational velocity. So just by definition, right out of the box, that's what a different system is going to put out.
And re-educate me, rotational velocity. I mean, treat me like a sixth grader. Rotational velocity is,
I believe what that is, that says how fast are you going to rotate around the center point of your robot. And again, by definition, on like say on the Ackermann vehicles, we put the center of rotation, or we put base link at the center of rotation, and the center of rotation is between the two back wheels. So you've got all that figured out. That's where your base link is right now. And if we're running a TurtleBot, which is a differential drive, the center of rotation again is between the two drive wheels, but it's probably going to be in the center of the center of the vehicle. So what rotational velocity means is how fast are we going to turn around that point. So if you've got an Ackermann vehicle and you're driving straight with a steering angle of 0, the rotational velocity is going to be 0 because we're driving in a straight line. So if you turn it to some arbitrary left steer angle and drive forward, the thing is going to drive in a circle. So I'm just, again, during my 4 or 5 hours of not sleeping last night, I was thinking about this, and I was trying to think, how can you get rotational velocity out of an odometry message, and how can you get it out of GPS, and how can you get it out of an IMU? And it seems like by definition, if I take the current steering angle at time 0, and then at time 1, I read it again, it says, oh, well, now we're 10 degrees from where we were last time. Well, if we're reading that once a second, then by definition, that says our rotational change or rotational velocity is 10 degrees per second. So if we continue moving, so we started off at 0, and at 1 second, it says 10 degrees, and at 2 seconds, it says 20 degrees, and at 3 seconds, it's 30 degrees. So the delta between each one of those is what? No, that's not correct. Rotation, that's actual heading, the change of heading that you're doing. So rotational velocity, no, that's still the right value. So if it goes 10 degrees, 20 degrees, 30 degrees, 40 degrees, and you say per time, well, that says we're rotating 10 degrees each time stamp there. So the rotational velocity just says this is how fast I want the vehicle to turn as it's driving forward. That's the definition of the rotational velocity. And
so
they have various ways they can control the steering.
It's a combination of angle and speed. It's not much different than radians per second.
Yeah, correct. And the thing is, well, technically that is radians per second. That is the whole point of rotational velocity. You specify it in radians per second. And so the difference is if you switch over the TEB planner and say, well, I'm going to give you a steering angle as opposed to a rotational velocity, you're saying, okay, set the wheels to this angle, and then you have to get everything worked out so that it turns the same amount as what the rotational velocity would be. So they've got two different ways to define how to control the steering. And so that I've never completely figured out how to go directly from one to the other, but someday somebody needs to figure that out.
There is nothing about my code at the moment that even attempts to provide radians per second calculation.
Well, you don't have to have that at this point, because you went to the TEB planner and said, throw out radians per second and give me a steering angle. So you have changed the entire definition of your command velocity from rotational velocity over to steering angle. So you don't need any code to convert that right now because you said throw it out and go with the TEB planner. So your code should be dealing with a steering angle coming from command velocity. And my thought is that since Matt defined this to run, scale it to the joystick, which we don't know if the plus and minus one there was meant to be plus and minus 1 radian steering angle or plus and minus 100%. He was never very clear on that when we'd question him on that. So, but back to the fundamentals, your low level vehicle either has to respond to rotational velocity or to steering angle. And it's all, which one you use is now dependent on the TEB planner. If you've got that checkbox set that says throw out everything else and just supply a steering angle instead, then that means your command velocity has to be steering angle coming into your vehicle, and it has to be able to turn to that angle. That's what you're trying to control to.
Okay. Well, thank you for thinking about it in the wee hours of the morning.
But without changing a lot of stuff, I'd say if you just change that scaling on your command velocity mux and say, get rid of the thing that's clipping it to 0.3, and then down below, pass the value directly through, that means the TEB planner can put out up to 1 plus or minus 1 radian of steering angle. And that's got a much better chance of it driving correctly than what you have right now. The other clue is if you look at the TEB planner and you look at the parameters, it says, here's the checkbox, true or false. Do you want to use steering angle as opposed to rotational velocity? And then it goes on to say, this was put in so that you can use it with the stage simulator, because that's what the stage simulator wants, is a steering angle as opposed to a rotational velocity. And then it says, if you set that, it will now put out a value between plus and minus pi over 2, which means it's putting out a maximum value of plus and minus 90 degrees for your steering. Well, I'm going to guarantee you can't turn your steering 90 degrees on your lawn tractor. So they've already set one limit there as to how far it can turn. And then I think if you go into the parameters that say car-like tuning parameters, what do they call it, and set things like minimum radius and all this other stuff, you could probably limit the TEB planner down to the point where it's going to use a far less aggressive steering angle than that default plus and minus 90 degrees that it says. It says that's the maximum it can generate. So you want your vehicle to be able to take in whatever angle you send it, set the steering to that, and then hopefully that's close enough to make the thing run. Oh, I did have another question. I know Matt was running his tractor around, and he was at AgBot Challenge. I think at that point he was running the Pure Pursuit planner and generating points somehow with some other program, and he was making that work. Does anybody know, did he ever have his lawn tractor running with, say, the TEB planner and, the stuff that you guys are trying to run right now? And then the other question is, when Juan set his up, I believe originally he was running the Pure Pursuit planner, which is the one that we know works because we saw it working at AgBot, and Juan was driving his around. Has anybody taken the so-called quote, the standard code that everybody calls the simulator? Has anybody got that to run on a lawn tractor at this point?
Can you repeat the question?
Let me abbreviate that question. Have you had the standard move base flex with TEB planner running your actual lawn tractor?
No. I never use move base flex in my tractor. My tractor only had move base.
Have you got move base to run your tractor and make it drive reliably?
Yes.
Well, right there we have an example of something that should work. Now, if you're using move base, are you using the TEB planner with that, or are you just using the standard local planner that it had?
The standard local planner. But take it with, I don't know how to say it, with clips, what I'm saying.
Okay, say that again. You are or are not using the TEB planner?
No, I'm not using the TEB planner.
Okay, so if he's not using the TEB planner, that means he by definition is using rotational rate to control his vehicle, not steering angle. But he does have an example of his vehicle will respond to the navigation stuff that he's got built in there right now.
Ask the question, Juan, have you ever successfully issued a 2D nav goal on your physical tractor?
No. The only things that I have run, but I will check that about the tech planner because I don't want to say something that is, I'm not sure. Was the common velocity and nothing more.
Yeah, see, command velocity doesn't exercise the navigation stack, move, base, flex.
Yes, but I never got move base flex. I never use it. The first time that I use it was when we get the simulator and when the second version of the simulator.
So the reason I asked that was, I just want to know, has anybody got a physical vehicle to run using this combination of software? And apparently the answer is no, is what I'm hearing.
Matt says he did, but I mean,
No.
never, I mean, I don't, he never shared, you know, in detail.
One thing that
exactly how he did that.
I'm not sure is that I get the robot running the tune-up goal, but I didn't reach the goal. I'm not sure if I get the tractor moving towards that goal and I have to switch it down. That's something that I'm not sure. But I didn't done something that I can analyze and be sure about it. Because that was where I began having problems with the electricity of the tractor.
So my suggestion is, if people are going to jump right to a 2D nav goal as the way to test these fundamental things out, is you take it out in your yard, you point it straight ahead, you get a 2D nav goal directly ahead of the vehicle out some distance and verify, will it drive to that point in a straight line? And then do it again with a slight curve to the right, you know, pick a point off to the right or a point off the left and see, will it then correctly turn and drive to that, and keep making that bigger and bigger to see if you reach a point where it's not going to do that anymore. You see where it falls apart.
Yes, that was my plan, but I couldn't achieve that. Because when I try to do that, I get, I'm not sure if the error was something about the measures that I was trying to put the distance that I was giving to the tune-up goal. I'm not sure if it was something, an error of me putting data that it was impossible to achieve. That's something that is always in the, I don't know how to say, in the room, because we are not sure if we are giving data to the tractor that is achievable. So we have to narrow that to something similar to what you are saying. One of the things that I was thinking of doing is that to try to get the points of the GPS and find them in the simulator and understand if I was giving something that was achievable.
So Juan has just introduced another problem that he's trying to navigate on GPS, which, as Al says, use 2D nav goal, you're bypassing all the GPS. You're just going directly into the nav stack and saying, go to this XY location, and it should know its current location and current heading, And by specifying a 2D nav goal, you're specifying a new XY offset and a heading for it to drive to. So,
Yeah.
yeah, again, the more stuff you add on top of it, it's still down to the point where you got to get the steering to respond to the standard values that are coming out.
Yes, I understand what you're saying, and I think that you are right. We have to simplify it. That's why I'm trying to get the test. I was trying to listen to the test that you were saying about the angles of the steering wheel. The test that I ran when I got the tractor moving wasn't the test that I should done. It was an error. I was trying to achieve things overcomplicated. I have to load the bar to try to achieve, to get information about what are the problems that I'm really facing. If you get a lot of problems in the bag, you are not sure. So I have to load down and make this smaller.
Yeah, just getting a straight ahead 2D nav goal test to me seems like a big enough challenge.
Yes, but if you recall all the things that we were talking, it's always getting lower. We began with a lot of bigger expectations, and we have to come back to earth and try to, from there, build the working plan. Because that was why the first thing to say, try to run a common velocity, a simple common velocity. If you can run that, that is that the robot can understand that command.
But if you're running a command velocity command that is not correct, then you're not solving your problem. So you have to scale it to the proper thing and get that to run. You know, if you say turn the angles to 10 degrees, you expect your wheels to turn to 10 degrees. If you're saying put in plus and minus 1 and you don't know what that means, then yes, you can get it to run with that command velocity message or like directly from the joystick. But if it's not what the navigation stuff wants to see, that's not solving your problem. So like Al was saying in this problem, he decided, well, his velocity might have a problem also. So if you can get his velocity to respond to the correct standard value from command velocity, which is meters per second. So if you can put it in, say, 1 meter per second or half a meter per second, get it to drive forward at that speed and verify all that works. And then say, since he's using the temp planner, he has to have a steering angle. So if you put in a steering angle, say pi over 4, which is pi over 4 would be 45 degrees, and then you expect your steering to turn to 45 degrees. So if you can get the steering to follow the angle you put into the command velocity and get it to follow the speed you put in the command velocity, then theoretically you can type in a command velocity message and have it drive where you expect it to go. And then you can worry about starting to put navigation stacks and GPS and all this other stuff on top of that.
I thought Matt just did a simple cut and paste of Daniel Snyder's command velocity mux, but obviously he didn't. So
I think you'll find that there was a lot of hacking going on, and you know, he was like everybody else, he's always in a hurry, and he just did whatever it took to make the numbers come out, and maybe didn't quite define them exactly where they're supposed to be. So but anyway, you just said you're talking about the Daniel Snyder command velocity mux. Well, at this point, forget about that completely. Make your tractor drive based on a command velocity message, and don't worry about command velocity mux and your joystick and your navigation stack and all this stuff. You got to get the fundamental thing to do what it's supposed to do. By definition, if you say turn the steering angle to so many degrees left, you want the steering to do that, and regardless of navigation stack or joystick or anything else. Once you get that, then you can say scale the joystick to that particular angle And then you could go back to driving it with a joystick and everybody will be happy. And then as soon as you just fire up the TED planner, which is putting out angles, it will automatically match what you need to make the thing drive. And at that point, I say then add in the TED planner. Well, then if you're going to put the command velocity mux back there, yeah, you're going to have to rip that extra stuff out of the command velocity mux. That's I think working against you at this point. But again, you got to get the fundamental tractor to respond to that command velocity, regardless of any of this other stuff that's running in ROS. And when I say get it running, if you were to set it up and you think that the steering is, just sitting there not moving at all, and you put in a command velocity command that says turn the steering to, say, 30 degrees to the left, and then watch the tractor sitting on the floor. Does it turn the steering to what you think is 30 degrees? And if you have to pull out a protractor and measure that, and if you can get that to follow the angle that you give it, then as once you get at that point, then you can take it outside and you can drive it around and verify that if you say turn 30 degrees to the left and give it a forward velocity, it should drive in a circle going around the yard like you were doing before. You said you were putting in either a +1 or -1 and a velocity of close to 1 meter per second. You said go forward 80 meters or whatever. And then it would, I think you said you took a tape measure and measured the circle that it created. Well, you can go back to things like that. Once you get you could specify the actual steering angle, specify the actual speed, and then go out and measure, say measure the circle that it creates. And someday we're gonna have to go look at that. There's a little graph or a little picture if you look under TEB planner, there's a node that says convert rotational velocity to steering angle. And they've got a real nice picture there saying, here's a picture of the vehicle, just a little like line drawing. And it's saying, here's the center of rotation over here, because the center of rotation out in the real world is going to be defined as a line drawn through the two back wheels. That's draw that line out to infinity. And then as you rotate it around, then the line from your wheel up here, say your wheels like this, you draw a line through the axle like this till it crosses that imaginary line out there. And that should be the radius of your turn. So there's little checks you can do there and say, if I set my steering to 30 degrees to the left and drive forward, that should give me a circle that's going to be approximately this size. So there's once you get to the point where you can do that, again, before you continue on with navigation goals or anything, verify that you give it these commands and the thing goes where you expect it to go. And I think you're going to be light years ahead if you can, get it to fundamentally do that. I had another thought while I was going through that, and I can't remember what it was. Oh, I know what it was. So you said you went out in your yard and you drove your tractor. You said give it a +1 or a -1 for that field in the command velocity, and you said you had to drive around, and you measured something like 13 feet was the diameter of the circle is drawing. That seems like an awful large diameter. I know when you first got your lawn tractor, you're complaining, these things turn too darn sharp. How do I mechanically keep it from doing that? And somewhere I was seeing that they're talking about Cub Cadet lawn tractors. They said something about if you use the brakes, so this might be a fancier one than what you had, but they said you get like an 18-inch turning radius on this thing. And 13 feet would give, that'd be a 6.5 feet turning radius. So it seems like even at that, if your wheels were all the way to the left or all the way to the right, it seems like you should have had a much smaller circle than that when you're driving around. But maybe I misinterpreted what you were doing there.
I have to go back and look. I think I measured the outside wheel, not the inside wheel. So you gotta.
And technically, what you're going to want to know is the diameter from base link, which is halfway between those two wheels. So in that case, if you take the outside one and the inside one, and you can figure out, what's the difference between the two back wheels, and you say go halfway between the two diameters, that'll tell you how far it was turning. But still, it just seems like that's an awfully large circle for what you said you did.
And again,
So that's just another thing you can look at and say, does that just common sense? I tell it to do this, it should do that. So if you got on the thing, say if you still had a seat and you still had a steering wheel and you crank the steering all the way to the left and you drive forward.
Yeah, I don't crank it. I mean, I don't, in my in my physical implementation of my motor, I don't jam it all the way to the right or to the left. I just don't.
Do you get close to the right and the left, or do you
Yeah,
only
I
go
mean,
like
I get
halfway? Or
close, but I purposely don't
yeah, when
jam
I
it
say
all
at
the
the
way
hard
over.
stop, I'm not saying slam it up against it. I'm just saying, that's your full range of travel. And you do have to be careful too, because depending on your software control, if you don't have good control over it and you say, well, stop a little bit short of my hard stop, well, if your software isn't working and your software, is banging back and forth like this, it sit there and bang into the hard stop when you get over there. So yeah, that probably makes a lot of sense to not go all the way in the first place. It's just that seemed odd to me that that's all the sharper you could turn based on the numbers you said you're putting into it.
My recollection is it was the outside diameter. So because my recollection again was in the documentation that I found, that's what it was looking for, was the outside wheel, not I'm trying to find the post now.
It, in my case, is the outside wheel.
Say that again, Juan.
That in my case is the outside wheel.
Yeah, I mean, there was some question in my mind what it was looking for, and I just chose the outside wheel, I think.
And that's going to depend on everybody you listen to is going to give you some different opinion on, say, oh, go check this or go look at that, or it's defined on this. And then you find somebody else says, no, it's exactly opposite of that. So it's just more stuff. You just have to keep digging and looking at different people's opinions and see what they say it's supposed to be. And again, you just want to get something that seems rational to you, that, is that something you can live with? Or is it, see, what you really want to do is fundamentally figure out, what is this supposed to be doing? If I turn the steering this much and drive forward, it's going to make this circle. Does that seem like it's doing the right thing? I guess was my point.
So you have nightmares. Technical nightmares.
Yeah. Well, this
Yeah,
is
minimum turning radius.
You know that I have the same. This week, I was working not the whole week, but I think every day half an hour to try to make the blue pill work. And today at 5 in the morning, I get it working. I was able to put it in the Arduino. So we are maybe not the same nightmare, but it's the same. I don't know how to say it, but it's a technical nightmares. And the other thing is that I get today my actuator for the. So now I have 2 actuators. This is like something that I can use if I broke the one that I have. The other thing that when you were talking is that when we were working here with Matt, we were talking to put a potentiometer in the front wheels to try to get the angle of the wheels, because as you began working, sometimes the tractor began having problems in the wheels, in the right and the left wheel. So maybe they won't be the same and you will have an error there. It wasn't an easy task, and the only thing that we come out that we can use was to try to print a 3D plastic case to get the actuator, but we couldn't find a way to connect the actuator to I don't know how to say it in English, but la punta de dirección, the wheel angle arm. But that was something that we were talking about to try to solve it.
There are actually several places in your steering linkage where you could measure it. And yes, if you put something right on the front wheels, which I think Al has something right, do you still have your sensors on your front wheels to measure the angle? Or did you take those off?
No, I have two angle sensors, one a low resolution. Both of them are, neither are on the front. They're both
Yeah, one on top of the motor and the other one is on the big
down at the,
gear
yeah,
down
the half
below. Is that
gear.
correct? You got the pot is on the gear like Matt did. And if you were to then put a sensor, say either right on the front like you had it, or you know, like the, for instance, you know, everybody talks about the Delphi sensor from the car that has it's a round thing with an arm on it, and you move the arm back and forth. Well, something like that you could put on the front. So the arm on that's pushing back and forth, connect that to the push rod. So as the push rod moves back and forth, you know, it turns the arm on the thing. Looking to see if I had this other one here that. Well, it's not handy, so I can't show that, but there's various ways you can measure that. And if you have something, say if you're measuring the motor shaft itself, then there's several things in between that could go wrong. You know, something could break, something could slip. Even your sensor on the motor could slip. So yes, if you put something all the way out to the front and measure at least one of the two front wheels, those two should track. So as your motor turns, the sensor on the motor should be some ratio and maybe an offset to one of the front wheels. And if you're to measure both front wheels, then if for some reason, say if you would bang into, Matt kept talking about running into the house or running into trees or something, which could, you know, screw up your steering. So yes, if you had a way to measure both front ones just as a verification to know that not necessarily for control, but just to know that they no longer match the sensor back on your motor or on your big gear down there, that would be another handy thing to have. And that's one of those things where, you know, eventually you run out of other things to do. You can say, well, let's add that. So it's a good debug technique. So it just automatically, every time you turn it on, it just says, I expect these two numbers to be tracking. And if they're not, that says you've got something wrong in your mechanical system. Or like in Juan's case, where he had a broken wire going to his sensor, you know, then if he would have had the sensors on the front, it would have said, you know, those say they're right, but the one on the motor isn't working or says it's wrong, then that would have given him a quick indication that just the fact that the two don't match, that there is a problem there. And kind of on my thing where I decided it was going to be a research vehicle to test things, I was just going to put lots of sensors on, and I may or may not, you know, add more. Because right now on my mini tractor, I just have the RC servo on there that runs the steering back and forth. And I've got the wire soldered onto the pot, but I haven't done anything with it yet. So that can give me a feedback for the actual steering. And then I was going to take one of the thing that's like the Delphi sensor. I thought I could mount one of those underneath and hook it to the control arms that go back and forth. And that would give me an indication of the angle. And then possibly put something right on the wheel like Al did, where he was doing it right at the wheel to measure the angle. And then that gives you several options. Number one, in your code, you can go out and you can compare those while you're driving around, and they should all be tracking each other. Or you can go back and say, somebody says they just want to put an angle sensor on the control arms. And that's what I think what Kyler was doing when he started out. He just took one of those Delphi sensors and bolted it onto his tractor and strapped it onto the control arms to get his steering angle back. So if I had, say, 3 different methods to measure, I can just go in my code and say, well, let's use this sensor and verify we can drive around and do everything we want to, or use the sensor on the RC servo and just use that one, or just use the one on the wheels. So that way you can pick and choose, you know, different techniques. Because somebody's going to say, well, I don't want to do it the way you did. I want to do it this way. Will that work? And I can say, well, here, let me go turn that on, and we'll see what that's doing for us. So it's back to the point that you could have all these multiple sensors and different types of sensors, and they all complement each other. And like I was saying earlier, I don't know if I finished that, but I was saying, say on my mini tractor, where I've got the rear wheel differential drive odometry, and it puts out my X offset, my Y offset, and my heading offset from where I started. So if I start at 0, 0 as I drive around, that tells me where I'm at. And yes, it will drift, but that tells me that. And plus on the standard odometry message, it generates it recovers the current forward velocity and the current rotational velocity. So right there, by looking at mine, I should be able to just look at that number and say, is the rotational velocity coming out match what I put into it? So that's a good way to check. And then theoretically, if you have an IMU, I don't know if the IMU messages actually publish a rotational velocity. They probably do, because it's probably the yaw, what do you call it, the yaw rate. Now, I don't know if that makes it out to the ROS topics or not, but the IMU does know by default what your rotational velocity is. And that's actually something calibrated right into the chip. So that might be one of the closest ways to verify against anything else. So that's a second source of rotational velocity. And then if you go to your GPS and take off the heading value from that and do a couple calculations, you can say, what's my change of heading per time? So that your GPS could also generate a rotational velocity. So theoretically, if you have all three of those running and go out and drive your vehicle around, either with a joystick or with command velocity or with a nav goal with the navigation stack, as it drives around, all three of those numbers should be tracking each other. They might be off a little bit due to calibration or whatever, but that's three different ways you can get that information back out. So I thought one of the things I could do if I weren't so lazy, and if I stay up all night thinking about this stuff, the next day actually do something, I get something done, but I'll probably just watch TV all day. But what I could do is I could take that node from the TEB planner. They've got that node that says convert rotational velocity into steering angle. And if I take that, there's only like 2 or 3 lines of code in that actually do anything. But I could get it to the point where I actually define a command velocity message in forward velocity and rotational velocity, which is what everybody else in the world other than the TEB planner uses. And then I could feed it to that node and convert that to steering angle and feed that into my tractor and have it control the steering to what I think that angle is, and then start driving around. So if I say command velocity, drive forward 0.5 meters per second and turn at a rate of say 45 degree or an angle, or no, at a steering rate of whatever, one radian per second, whatever it comes out to be, let it do all of its calculations all the way through. Now reading those other 3 sensors I have, they're going to tell me what the actual rotational rate is on that. And so if I set all of it up and the numbers is off by say a factor of 2 or a factor of 10 or not even close, then I know I really screwed something up. But if I would get to the point where I could put in a rotational velocity and a forward velocity, and so that node from the TEB planner is going to say, oh, here's your steering angle it should be set at. But the point is, if I put in a rotational velocity, I should be able to read it back out of the sensors and have those two match. And that's, as I say, that's one of the fundamental things that it has to be able to do. You have to be able to know that before you can start adding all this other stuff on and expect it to work. Now I know I'm going to confuse Al again and he said, oh, I don't want to use rotational velocity. I don't need to know all that. And yes, if you're using the TEB planner, technically you don't have to know that. But as one of my verification steps, I was thinking that's something I could do to verify that, number one, that does work, and number two, that I know what I'm doing. And it could be that I'm going down the wrong path, that if I specify a rotational rate and convert that to an angle, it could be I'm doing the wrong thing. Maybe that's just not at all correct what I'm trying to do. Originally, 2 or 3 meetings ago, I said I saw a statement that said this generates a steering angle, but it's not actually the angle of the wheels, it's the angle of the vehicle is going to travel. And I can't find that statement anywhere. So I still don't know which way that actually goes. It could be the angle of the wheels is the angle the vehicle is going to travel. Maybe they're one and the same. I don't know. But if I get around and run that little test I just said, that would tell me, I've got all the pieces all the way through to figure out if I say turn at this rotational rate and turn it loose and then read the sensors, if they don't match, then something along my whole chain is wrong. My concept is wrong, I guess is what I need to say on that. But I don't know if I'll get around to do that today, so or ever.
Juan, anything else to share?
As a final thought here, what I was
Go ahead, Jeff.
what I was looking at when I first came on, and Al wondered if I was looking at diamonds. I have this that little it says my internet is unstable. I don't know if you're getting me right now, but it's that little board that I bought on. It's an A to D converter. If you buy it from Adafruit, it's a 16-bit A to D converter. If you buy it on Amazon, that doesn't say Amazon or doesn't say Adafruit, it's a 12-bit converter. And I complained about it and said it was a counterfeit part. And they wrote back, says, "Oh, well, based on all the information we have, no, that's perfectly fine. We deleted your evaluation." So they're hiding the fact that it's the wrong part. And if you go look at the comments on any of these out there, everybody's saying, well, this is actually a 12-bit part, not a 16-bit part. But since they didn't use the word counterfeit, they didn't delete their complaint. So what I did was I finally got around and got some fingernail polish remover. So I took my Q-tip and rubbed it on the top of the chip. And sure enough, the silk screen number that was on there did rub off. And I'm down to the point I can almost see something that's on there, but it looks like they sanded the chip first. But I could just faintly see the original numbers that are on there. So that's what I was doing when we started the meeting, because I think it's a valid part. It's just that they put the cheaper 12-bit part on and remarked it as a 16-bit part so they could sell it for twice the price. So someone along the chain cheated. They knew what they were doing when they remarked the parts. Now, whether or not the company that copied the board, because when Adafruit puts this stuff out, they say, oh, it's open source. So here's this little open source board. And they gave all the schematics and they gave the layouts and everything. So people in China just take all those layouts and make their own printed circuit boards and then go out and buy chips and solder on. And then they sell them on Amazon and eBay. But the problem is, we will never know if the people that made the board and are selling on Amazon purposely had those chips remarked, or if they just foolishly went out and bought 10,000 chips from some company that says, oh, I'm selling those for a cheap price, and put them on there. So you don't know where in the chain somebody screwed this over, but then Amazon's trying to cover it up by saying, oh, we don't know. That's fine. So that's what I was doing. I was looking at that.
But it's definitely not a 16-bit chip.
The one on this board is not, no. It works just fine. It works as if you want a 16-bit chip with differential input. It works just exactly like the chip that it actually is, as opposed to the one they remarked it to. And if you buy the one from Adafruit, it's an actual. The one says Adafruit on the back, and it's got their little logo, that little dot right there. That's a little Adafruit star. That says it's a genuine part. There's nothing that prevents them from silk screening that on and selling it, as a total counterfeit part. They could do that if they wanted to, but I took a chance and bought the one on Amazon that said it was from Adafruit, and apparently it is, because it's an actual 12-bit part. So if you want 12-bit parts to do for whatever reason, they work just fine. They work great, and I'm really happy with it. It's just that I'm annoyed that they're lying about the fact that it's a different part.
I want to ask Al, the last meeting we were talking about how you get all your sensors working together. And we understand that you have more than one Arduino working together. How you pair them?
How do I pair them?
Yes. How do they work?
His question is, you've got multiple Teensys running. Do you have one copy of ROS serial running on ROS, or do you have a separate copy of ROS serial for each Teensy? I think was his question.
Separate copy of ROS serial running on each Teensy.
But on the Linux machine, do you have one copy of because you have to have something like ROS serial Pi or something running on your Linux machine in order to talk to each Teensy out there. So the question is, do you just have one copy of that and all the Teensys use the same one, or do you have multiple copies of that running under Linux?
One version of ROS serial running on the Pi, and each Teensy publishes a node, and I read those topics in on the Pi as I need them. So Let me just share quickly.
Maybe it's important to look to your raw serial configuration.
Well, I mean, here's this is the code that runs on the Teensy that controls the transmission. So this is not running on the Ubuntu RPi. This is just the, and it subscribes to command velocity, which is being published by the RPi. It subscribes to,
No, it publish.
no, it doesn't publish, it
Okay,
subscribes.
okay. Sorry.
It subscribes to the speed that's being published by the Teensy that monitors the speed of the left wheel, and it publishes the PWM that it sent the transmission, so I can monitor that.
Well, we're not looking for that kind of detail. We want to know, in order for ROS to talk to your external device, when people wrote up ROS serial, they created a node that runs on, runs under ROS, and it connects over a USB to an Arduino, and then the Arduino, they talk back and forth over that interface. So the question was, if I have multiple Arduinos plugged in on separate USB ports, is the ROS serial node that runs under ROS, is that smart enough to know you've got multiple devices plugged in? I just assumed you had to have a separate ROS node for each Teensy that you're talking to, because you have to start up that ROS serial node and then say, this is the COM port I want you to talk to. And I don't know how, so I've never used ROS serial. I'm just theorizing which way that might actually work. So
Well,
regardless of what the messages are going back and forth, the point is you have to have communication between the Teensy and the ROS machine. And now if you have multiple Teensys, the question was how does the ROS machine know that you've got multiple devices, and how does that communicate to that?
Every Teensy, you have to have a ROS serial. You have to start ROS serial for every Teensy that you start.
Okay, that's the answer he was looking for there.
Okay.
So in where's the launch file? The launch file. I have that handy. Teensy launch.
It was 2 files under in the there.
So each one of these Teensy gets ROS serial Python node.
So Juan, does that answer your question?
Yes, but I don't understand the code, so we have to try to.
This is just a launch file, and as one entry in the launch file says start a node that's called transmission Teensy, and it starts up the ROS serial Python node, And then I don't know if it's got the name of the port there or whatever. So you've got a separate program running on ROS that will talk to that particular Arduino or Teensy you've got out there. If you want to add a second one on, you have to add, like he's got 4 separate lines there. He starts up the ROS serial Python node 4 times because he has four Teensys plugged in.
Yes, yes.
This
I
is
think
a, this is a UDEV, just so you know, this is a UDEV.
that's the part that I'm not understanding. You declare UDEP rules for
Yeah.
each one.
So that's
It's a UDEV
renaming.
rule.
That's renaming like TTY ACM 0 to this name here. He did that somewhere else and he's just telling it here. That's the particular port that you want to use.
Yes, 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 yes.
So
No,
each of those has a serial number, manufacturer number. So there's a UDEV rule that links it to a specific board.
Okay. Okay. Okay.
So that's how it distinguishes the physical board.
Okay.
And quite honestly, with Teensys, that's a really tricky little thing because I crashed a number of Teensys with that whole process.
Why do you crash them?
Well, because there's some peculiarities with Teensys that in the UDEV rule, it wouldn't recognize the serial number. I'm gonna have to remember this.
No, yes, okay.
I'd have to pull up my UDEV rule and try to remember exactly why. It had to do with Teensys and the serial number. There was something going on with the serial number on Teensys. I'm sure I have an explanation on it out there somewhere.
It's in the Teensy configuration file.
I'm sorry, what?
It's in your Teensy configuration file when you boot up, when you configure the Teensy.
The UDEV rule? I didn't understand the question.
Yes, yes, yes. The UDEP rule, as you mentioned, you use it when you configure the Teensy board.
Well, the UDEV rules are you know, you only have to set those up once.
And the UDEV rule is just a way to assign a fixed name to a device when you plug it in, which has nothing to do with ROS. It's just a complete Linux trick that you can do. And yes, you say in the Teensy configuration, it uses that new name. Yeah, you can use that name anywhere you want once you've created it. So Al was just looking for the point where he actually created the UDEV rule and based it on the serial number of his parts, so it knew what was going on. And it's really handy if you've got a device that has a serial number, because if you buy, say, the cheap $2 or $3 Arduinos, like the Arduino Nanos, those all look exactly the same. So now you've got a problem on those because it can't recognize the difference because they all say serial number 1 and they all say whatever. So it's real hard to get those right. So on the Raspberry Pi, what I did, I just went to physical USB port, static port naming. So I said the first port is so it says the first port I'm going to call GPS and the second port I'm going to call laser scanner or whatever. So I just went down the line, and I didn't have any way to identify the different modules. So I just went to the actual, it said if it's plugged into the USB port, it's going to be this type of device. which actually you do have a slight control there, because under UDEV rules, you can say, number one, it must be an Arduino. There's something in there that tells you that it's what type of device it is. So you do that, and then you say if it's plugged into the first port, then it's going to be, say, the laser scanner or whatever it happens to be.
I mean, if you look on G Drive and you just search on Teensy, you'll see some descriptions about how I set up the UDEV rules. I mean, here's one of them.
No, because it was a low profile chat the other day. We were talking about this because I was trying to understand how many Tensies did you have in your setup, because I only have one. That was the main thing.
The answer is I have 4 at the moment,
Okay. And
plus
why?
plus the RPI,
Why do you have 4?
because I didn't want everything. I wanted to use USB, and I didn't want everything run through one. And I wanted to separate things out and have small things instead of one big, large thing.
Okay.
So
So I have,
there's actually several things there. That number one, if you've got several small processors, you've got the code for just that one device running on it, so you don't have to mix the code. You don't have the code for, say, in this case, all 4 of those things running on the same processor, so it's easier to keep track of. Another problem you can have, Al was connecting his magnetic sensor to his Teensy over I²C, and if you get that more than 2 or 3 inches long, you start picking up enough noise that causes a problem. So he just put a Teensy right next to his magnetic sensor, and then runs the signal back over his USB to get it back in. So it's a combination of things there. You don't want to get your electrical interfaces too long because it can cause problems. So you can put multiple processors, or it's just simply the fact that if you got a Teensy that's only doing transmission control, then you don't have to try to make it work at the same time as doing steering and sensing other things. So there's a couple of reasons to do that. It's just a choice of how you want to do it.
Jeff's got a very good memory,
Yes.
because the IC squared thing was actually was a pain in the backside too.
Although one more thing to keep in mind, if you're going to have multiple processors and each one is publishing topics, keep in mind they have to talk over topics in the background. So you've got, say, you've got a steering sensor. It's publishing the steering, it has to go all the way to Ross, and then say your steering controller then might subscribe to that. So you're passing all these topics around, instead of, if everything is on the same microcontroller, you could say read the steering angle, read the whatever, read all these different things, and they're right there in front of you in the code. So you're not passing all these extra topics around. Which brings up another point from last meeting when Al wasn't here. I was noting that you were showing your diagram of what comes out of what the liner robot stuff, where it's got the diagram that shows here's a joystick, there's a joystick node, there's command velocity mux, and then there's the TEB planner, and all that stuff's connected together. I was noticing that on your system, it looks like you have the joystick plugged into your laptop, and then you've got the navigation software running on your RPi on your robot. And I was noticing that when you do that, your joystick is physically plugged into the laptop, so the Linux driver grabs that and puts out whatever numbers the Linux driver puts out. So your joystick node connects to that and publishes joystick topics. Now, I believe you also have the command velocity mux on the laptop, so that passes directly into that. But the other input to the velocity mux is the navigation stack from the TEB planner, which is on your robot. So it's having to generate a message and send that across to your base station to the velocity mux, and then it puts out a command velocity which gets sent back to the robot again. So now you've got extra traffic going back and forth. That if you just move your command velocity mux out to your robot, then those extra transfers would go away. And it all depends. If you've got a really clean Wi-Fi network, a really clean Ethernet, you can move stuff around all you want because it doesn't care. But once you start going over Wi-Fi and you start losing stuff, you don't want to send stuff back and forth any more than you really have to.
Yeah, I changed that by implementing a 2.4 gigahertz radio gamepad, and so there's a
Yes, but the main problem that that Chef is talking is not solved, because if you are throwing all that traffic to the network, I think that
yeah, but the receiver for this is now plugged into the USB on the RPi.
oh, okay.
So I took that traffic off of the Wi-Fi backbone.
So where is your command velocity mux program running? Is that on the RPi or is that on your laptop?
It's on the RPi.
Okay, then in this particular case, what I'm saying is not going to be a problem. Let me just back up and say my philosophy is, if at all possible, put all of your control stuff onto your robot and only put RViz on your base station, because RViz is the only thing it's doing is reading up data and displaying it. And if you lose something, it's not catastrophic. It's not actually controlling anything. As far as I know, the only thing that RViz generates is you can say set initial position and you can say set a navigation goal. And that's the only two things you're generating, and those are single messages that are going out. But as we also talked about the last meeting that didn't get recorded, when you've got two computers connected together on ROS, you can put nodes anywhere you want and it will still work. So you can put half your nodes on the base station and half of them on your robot, and they will connect together and they all work just fine. And we also discussed the fact there doesn't seem to be anything that tells you that that's what's happening. You know, you pull up, say, RQT graph, and it says, here's all these nodes just magically connected together. So you look at it, it looks like this, they're all connected, but you don't know if the nodes are on your laptop or if the nodes are on your RPi on your robot. So it's just something you just have to keep in mind, you know, where are the nodes located, what data is it sending back and forth. And
I did
if you
have,
get in a situation where you end up with a noisy network, what's that?
yeah, I mean, whatever, 2 months ago, I was, I could have been prone to having a noisy network. I took that joystick stuff off of the laptop for the reasons you're talking about.
So I will have to leave. See you next week.
Okay, guys, have a great weekend.
Bye.
See you, Juan. See you, Jeff.
Okay, I say it.